So you might wonder on why can't we just simply use files? We all learned how to actually use files when we learned basic programming. So if you have learned basic programming in C, we know how to do file handling in C, right? We have learned a bunch of functions. We have learned functions like fprintf, right? fscanf, if you recall, right? fopen, fclose, all of these, right? Again, this is as far as C programming language is concerned. Similarly, given any major programming language, whatever programming language you have learned, be Java, C++, Python, whatever it is, we have learned how to handle files. So big question here is, why should we actually do this whole database system, or why should we learn about database management systems while at the end of the day, DBMS is trying to store data? Why can't I simply use a file system to achieve this? What is it that the DBMS provides me in addition to a file system? Here, very importantly, one thing that you have to notice here is a DBMS actually ends up storing, see, at the end of the day, a DBMS ends up storing everything in a file. At the end of the day, it has to store it in files. Okay, it ends up storing everything in a file, right? Everything in a file. But in addition to this, it gives us a bunch of machinery. See, DBMS itself is a piece of software. Any major database that you can think of. Again, there are many popular databases like Oracle's databases by Oracle itself, which is one of the most popular companies in the software industry. There is MySQL, which is an open source, extremely popular database. There is also Microsoft's own SQL server, right? Microsoft SQL server. It's called SQL server, right? IBM itself has something called as IBM DB2, right? So all these are extremely popular software that some of the world's largest companies build and sell, right? So if you think about it, a DBMS at the end of the day is a piece of software, right? So what a DBMS does, in addition to just, if you think about a simple file system, right? What do you have in a file system? You have the ability, using all these functions like printf, scanf, fopen, etc. You can create files. If you think about it, you can create files, you can edit files, and similarly, you can also create folders. You can create files or folders. Similarly, you can edit, and edit basically means change or even delete files and folders. This is what a file system provides to you. What a DBMS does is slightly more than that. What a DBMS does is very interesting. If you think of DBMS as a software, look at this. This is your DBMS, right? Your DBMS is a software. If a software engineer is using the database, again, who uses the database? It is a software engineer. There could be a software engineer 1. Let's call it SDE 1, software development engineer 1. There could be one more software development engineer 2, right? There could be a business person who wants to obtain some data. There could be business person 1, etc. All these people end up using this software system. DBMS internally, within the DBMS system itself, there are many pieces. Okay, one of the pieces is a file system, right? So DBMS internally manages the file system, right? So very often, what you can do with a DBMS can be done with a file system, but a DBMS takes care of many of the details for you without you having to always build these details. So let me give you some examples here. Okay, some simple examples how a file system, a very bare minimum file system that you have encountered when you learned C programming, and how a proper database like an Oracle DB or a MySQL DB or a SQL server or DBT or DB2, how they fundamentally differ. Again, please understand that DBMS is just a piece of software, very powerful software, which can be used by others, right? So DBMS takes care of everything for you, and it internally uses the file system itself. Okay. So first and foremost, imagine I have my data. Imagine, let's take the e-commerce example itself. Imagine I have all the product data. I want to find all the products which are priced at greater than $100, right? So if you think about it from the file system perspective, versus the database perspective, right? Let's look at it from these two perspectives. You might have a file on your hard disk, right? The file itself might contain, let's say, okay, you might have a physical file. Okay, let me erase this here. So what you might have is a physical file. It's actual file. The file might have product ID, comma. Again, all this data is comma separated files. So what we're doing here is comma separated files. What we're doing here is comma separated files. Okay. So you will have a product ID, you will have product name, right? Product price, okay, and some other information. So you'll have product ID 1, comma, what is the name of the product? Let's say Nike shoes. Okay, product price $30. Again, in the next line, product ID 2, let's say MacBook. Okay, price maybe $1,000, so on and so forth, right? So this is how your data is actually stored physically, right? This is every new line. In each line, for each product, you'll have the product ID, comma, product name, comma, product price, etc. This is how the data is physically stored on the disk. This is how the data is stored on your hard disk, right? While in the case of DB, what happens is slightly different, right? In the case of a DB, what happens is you don't have to worry about how the DB stores the data internally. See, remember, the DB is this layer. DB is this layer. It stores the data internally for you. What a DB does, in addition to just storing the data, is DB actually does something called as indexing of data internally. You don't have to worry about this. So for example, imagine you have the data stored in a file versus the data stored in a database, and you want to answer this question. In the case of a file, what would you do? You would actually open this file using fopen in C. You would go to each line. You would see if this value is greater than 100. If so, you'll return that value. If so, you'll return this row and you'll print it. So you literally have to traverse through each line manually, right? You have to literally traverse through each line and check if each of these prices is greater than equal to $100 or not. If so, you print it. This is very, very time consuming as compared to, remember, this is very, very time consuming as compared to what a database does. What a database does is, see, at the end of the day, a database also stores the information in a file system. But what a database does is it builds some special data structures using something called as indexing. Okay. Again, indexing itself can be done in many ways. Okay. We'll learn about various strategies of indexing. What indexing does is it makes, see, your data, whatever data you have, the database itself internally stores it on some file. But in addition to storing it on the file, it also stores something called as an index. Thereby, instead of having to go through each line here, it can index much, much faster. Again, indexing can be, for example, without going too deep into indexing, we already studied some data structures and algorithms, right? So think about what are the simple strategies you can use to index. What is indexing? Indexing is, the objective of indexing is to make your search faster, or is to make your querying faster, right? That's the whole objective. And if you want to search data fast, search for anything fast, what do? We can use things like binary trees. If you recall, binary search trees to be precise. This is something that we learned in data structures, right? Binary search trees or hashing. These are simple strategies to make search faster. So DBMS internally uses data structures like binary search trees. May not be exactly binary search trees, but some very interesting data structures like binary search trees and hashing to make the search much, much more faster for you. So imagine if you're a software engineer. Suppose if you're a software development engineer 1 and you ask this question to your database. Again, you can query or you can ask from your database using a programming language called as structured query language. Again, you don't have to write code in C or C++. There is a programming language. There is a special purpose programming language called SQL, wherein you'll simply say, I want to find all the products whose price is greater than equal to $100. The DBMS internally takes care of where, see, it internally knows where this data is stored on the file. It also has the index, and you just literally give it one line of code and it would return to you all the products which are priced greater than $100. So all the headache of how to query fast and how to index. All of that is being taken care by your DBMS. That's one of the most powerful things that a DBMS gives us. Okay, so first and foremost, so instead of just using plain simple file system and being implemented in C++, it is better to use a database because it takes care of querying for us much more elegantly. Second, very important, redundancy of data. So DBMS avoids redundancy of data. What does redundancy basically mean in English? Redundancy basically means repeating repeatedly. It basically means repeatedly storing the same data. It basically means repeatedly storing the same data. Okay. So what a database allows us is it reduces redundancy, which means it minimizes repeatedly storing the same data. Because if you're repeatedly storing the same data, it will consume more disk space. Right? It will consume more disk space. We want to minimize the amount of space we need to store our information. Right? So we want to reduce the disk space. So what a database does internally is it actually takes care of storing all the information in such a way. Again, we'll have to guide the DBMS. DBMS is not some magic system. Okay. It's at the end of the day a piece of software. But it helps us avoid repeatedly storing the same information. Let me give you an example here. Suppose in a customer table, suppose I could have a customer table in which I have customer ID, right? I have customer name, right? I have customer address. I have customer address and multiple other details. In the purchases table, remember I told you that everything is stored as a table at the end of the day. Right? Everything in databases is effectively stored internally in the form of a table. Now in my purchases table or in my orders table, I will not store all the information of customers. What I'll do here is I will simply store the customer ID, the product ID, some information about the purchase itself, like purchase time, right? And that's it. I think this is good enough, right? Because now all the information that I want from the customer, like to which address should I send this product? That information I can get it from the customer table. So instead of storing this data, so this is one table, right? In this table we are storing customer ID, customer name, customer address, other information related to a customer. In the purchases table now, instead of again storing the information about customer address, customer name, everything, right? Because this customer ID is unique for each customer, right? So what I'll do here is I'll store it in such a way that I have a customer table and purchases table and the database internally. Again, I'm not saying this is impossible with files. It is certainly possible with files, but what happens here is a database internally, using a database internally, I can tell that whenever this customer ID is there, this customer ID is unique in this table, and any information about this customer, like the customer's address to which we have to ship this product, is available in the customer table. This sort of linkage between various pieces of data, I can easily do it using a database management system. And what this allows me to do, very importantly, is I don't have to repeatedly store the customer address again in the purchases table, right? I don't have to store it because this data is already present in the customer table. I don't have to repeatedly store the same information because I can simply say, given a customer ID, which is unique for each customer, you can obtain the customer address from this table. These types of links or connections between various tables can easily be mentioned to a database without having to worry about everything. Imagine trying to do the same thing in a file system. There is a lot of software that we have to write, right? So in a nutshell, if you think broadly, what a database does to us is it writes lots of software to make the life of software engineers who are using this database much more easy than software engineers who want to implement the same thing using files and folders. A good software engineers can also implement whatever a database is doing. They can do it using files, but they'll have to write 10 times, maybe even 100 times more code, which means it's going to take far more time. It's better to just use a database system which anyway does this for us. Now, another advantage that a database provides over a file system is called as consistency. Again, it is also possible to have consistency in file systems, but let me repeat it. Whatever a DB is doing, we can do it using a file system, just much harder. That's it. Okay. So for example, let's take this example, right? Suppose a customer wants to change the address to which he or she wants the products to be shipped, right? If a customer wants to change the address, what happens in this case? Now, in our current system, we have a customer table. See, in the case of a DB, what happens? In the case of a DB, I have a table called the customer table, right? And I have a table called purchases, right? I have a different table called as purchases. Now, when I want to change the address, I will simply change the address in the customer table, right? Because in the customer table, if you have seen earlier, we have customer ID, customer name, customer address. So I'll simply update the address in the customer table, and for every new order or any new purchase that the customer makes now, right? Any new purchase that the customer makes now, we'll start seeing the address. So let's assume there is an address here that is updated, that is changed. Now for all purchases, because all purchases will use the customer ID. Look at this. So this is my customer table. This is my purchases table, right? In my purchases table, I'll use customer ID, product ID, right? And some purchase time, right? So purchase time, right? Because this will actually refer to this table for all information. I will use the address, the updated address is going to be consistent for all the future purchases that the customer makes, right? Because of the way we have designed the table structure. Again, one of the big challenges in databases is how do you design the tables? Okay, designing the tables. Okay, designing the table structure. Again, we'll learn a lot about how to design these tables for databases using multiple examples, right? This is one of the biggest tasks in database design itself, which is how do you define what information or what data should be stored in each table, right? That's a very important task. We'll study this extensively throughout this course. But now here we get consistency in database because because for the database, we say that customer ID is unique. Look at this. We say customer ID is unique, and because customer ID itself is unique, for any purchase, if I just update the address of the customer in this table, it will reflect in all other places. In the case of a file system, this could be far more cumbersome, right? In the case of a file system, right, what happens? This data, again, this interlinking of data is not readily available. We have to write code. If you're using simple files, suppose if I store the data in file 1, file 2, if I just store the data, right? So I could have file 1 for all customer data, file 2 for all purchases. All these interconnections between this data is not readily available in the file system. All these interrelations are not possible. You will have to implement it yourself. Why bother about implementing all this when a database readily provides it for us, right? Because the database provides all these interconnections. Okay, all these interlinks to various pieces of data. You get consistency. What does consistency here mean? Now, whenever a new purchase happens, right, there is no problem. Every new purchase, because every new purchase has a customer ID, and since we have updated the address of the customer in this customer table, since we have done this explicitly, all new purchases now will start going to this address without any errors. Okay, so there is consistency of data, which means every new purchase is going to consistently refer to the original data where the address is updated, right? It's a very useful property. Now, similarly, there is something called as data independence. This is a very useful property, actually, if you think about it. This is a super useful property. See, let's look at this, right? This is your DB system. Okay, this is your database management system. If you think about it, this is your DBMS. There could be many people using your database management system. There could be one software engineer who is responsible for customer service, right? There could be another software engineer who is responsible for inventory management. There could be other software engineer who is responsible for search. See, each of them is building a product. This person could be responsible for search. This person could be responsible for customer information, right? There could be a business person who wants to understand how many dollars of sales has his business done in the last 1 month, right? All these people want to access the same information. Now, when everybody wants to access the same information, what if we hide the low-level details? See, the DBMS gives you a consistent framework, okay, a nice framework using SQL programming language. It gives you a simple to use framework. It gives you a simple to use interface, okay. It gives you a simple to use interface to query anything that you want, to ask anything you want from the database, to insert anything you want into the database, to delete anything you want into the database without having to worry about how this data is stored. So all these software engineers and business people need not worry about where the data is stored. They don't have to worry about how the data is stored. Okay. They don't have to worry about how to speed up searching this data, how to speed up or how to query the data. They don't have to worry about all these low-level details. The database internally takes care of you. They just have to ask what they want. See, SQL is a very, very nice language, right? With SQL, you just say, what do you want? With SQL, you basically ask what you want. Whatever you want, you ask it through SQL. DBMS takes care of how to answer your question, where the data is stored, how it is stored. You don't have to worry about it. Okay. So this makes life very simple, because for all the software engineers, business people who want to get their information, or who want to get their data, or who want to insert their data or delete their data or update the data, there is an independence here. Okay. They're not dependent on how the data is stored or where is it stored. All of that stuff, they don't have to worry about it. They just have to ask what they want using SQL. And DBMS internally uses all of its software and file system internally to give answers. So DBMS, you can think of it like a magic bullet. Okay. It's a piece of magical software to which you ask what you want, and it will give you whatever you want as fast as it can. So it hides all the low-level details. And that's why DBMS is a huge piece of software. Again, writing DBMS, if you were to implement your own DBMS, a powerful DBMS, it would be hundreds of thousands of lines of code, right? Hundreds of thousands of lines of code. And it's very doable to implement it. There are databases like MySQL, which are open source databases, which means you can actually go in and see the whole source code of MySQL itself, right? So I've seen some small pieces of code, not the whole MySQL code. I wanted to understand how MySQL understands internally. So I've actually gone and looked at some of the small nitty-gritty pieces of how MySQL optimizes things internally. Okay. Actually, if you have patience and time, it's a brilliant piece of software to understand, right? So similarly, security and access control. This is extremely important for an e-commerce company. Suppose imagine you have multiple software engineers, software development engineer 1. So you have an SDE 2, software development engineer 3, a business person 1, right? All these people. You don't want everyone in your company to have access to all pieces of information. Okay. For example, maybe you want the business person to you don't want the business person to have access to people's personal information. It's very, very important, right? You don't want them to have access to their phone number, because this business person may be only responsible for understanding how much sales is happening. Okay. Why should this person have access to every customer's personal information? Personal information could be their actual physical address, right? Personal information could be their phone numbers. If there is no need for a person to have access to this information, he should not be allowed to look at that information, right? Again, similarly, you could have a software engineer who is, let's assume he's responsible for all stocking. Okay. Suppose he's responsible for stocking the products into their warehouses. Why should he have access to credit card details of customers? Because this is very, very sensitive information. Even if one of these person misuses this information, it can be a huge deal for the company, right? So companies want to limit access to only those people who actually need access. Even at Amazon or even at any top tier company, there is a huge security protocol and access control to especially critical information, right? So for personally identifiable information, you require very, very high level approvals, and you require proper justification on why you actually need this information. Because this is very, very sensitive information. Even if one employee or even if one of these people misuses this information, it could be a catastrophe for the company, right? If you look at credit card details, nobody can access all the credit card details. Of course, credit card details are encrypted and all of that, but still, unless you need that information for your software or for your piece of software that you're responsible for, you will not get access to that data. And what a database internally does for you is, it allows you to create this security and access control automatically without having to write additional code. If you were to store all of this data in a file system, if you were to store all of this data into files, you will have to use a lot of operating system principles, right? You'll have to use a lot of operating system principles to give access control and security permissions. Database internally does it for you. For every user of the database, again, for a database, just like in an operating system, you can create multiple users. Each user will have some access permissions. So DB takes care of it for you very, very elegantly, right? And most importantly, what a database gives you is abstraction and ease of data access. At the end of the day, this is what a database gives you, right? A database is this huge piece of software, right? Wherein, what does abstraction here basically mean? I don't have to worry about how the database internally does what it does. All I know is that there is a customer table. Suppose if I want to access some customer information, all I know is there is a customer table, and I know this customer table has information like, for example, if I want to know how many people are from a given zip code, how many customers do we have from a given zip code or a pin code, right? All I have to do is, I don't have to worry about how the database works internally. As a software engineer, I know that there is a customer table which has a zip code information. All I have to ask the database is, tell me how many customers do we have in a given zip code. I just have to ask that question using SQL. I don't care how the database works internally. It will return the answer to me, right? So this abstraction, which means I don't have to worry about how things work internally. I just have to know SQL and what data is readily available and what tables are there. If I just know this, I'll ask the question and database gives me magically the answer. So it abstracts away all the complexity. It hides away all of the complexity of data structures, algorithms, file storage. It takes away all of those details from me and helps me do things that I actually want to do instead of worrying about where the data is stored. What if my hard disk crashes, right? All of the details, you don't have to worry about it. And it makes your life extremely easy. Again, I have seen databases being used by a wide spectrum of people. I've seen software development engineers use the databases. I've seen machine learning engineers and data scientists use DBMS. I've seen business people, okay, or sales people or marketing people, right? I've seen all these people actually write SQL queries to obtain whatever information they need to make a very informed decision about where they should, how they should improve their sales, or how they should design better business strategies, how they should design better marketing strategies. So all of this data, right? All of this data is being used. Again, this is even used by CEOs and CFOs, etc. Right? So database is one thing that unites everybody in the organization because it is the source of data and everybody wants to access this data, right? So as compared to a file system, again, let me repeat it. As compared to a file system can do everything that a database does, but you'll have to write hundreds of thousands of lines of code. Why bother about it when you can simply install a database management system which does everything that a file system that you want to do as far as a file system is concerned, along with all these huge advantages. It does a brilliant job at it, right? So if you want to store information or if you want to store large amounts of data, DBMS is the way to go. It's not the file system. And especially if your data can be stored in tables. Okay, that's why DBMS is one of the most popular. It's one of the most widely used. It's one of the most widely used pieces of software, I think, after operating systems in the whole of industry. Because everybody needs an operating system to even boot their computer, right? So after operating systems, DBMS is the most widely used piece of software in enterprises and companies.